So here we are starting graph series and we will solve all the 54 questions. Mm, all the 54 questions. So firstly, the first lecture is about graph. Mm, mm, So first lecture is about introduction to graph. Terminology is like nodes, and I think we know this, so we don't need to we don't need to watch the whole lecture. Undirected graph, three cycle, no cycle, one cycle, paths, degree of graph. It has 2 degree. It has 2 out degree, and it has in degree 1 and out degree 2 edge weight. So it's easy to understand. I don't think we need too much time on this C++ graph representation. Mhm. So graph representation can be done in two ways. One is adjacency matrix, and the other is adjacency list. Adjacency list. What is the motive of the list? And this is the question. So basically, in to represent graph, there is two way. First one is adjacency list, adjacency matrix, adjacency matrix. So basically, if graph one is connected to two and is connected to 2 and is connected to 3 is connected to 4 is connected to 1. So adjacency matrix will say that 1, 2, 3, 4, 1, 2, 3, 4. So we will create a matrix, matrix, and if there is a link between 1 and 2, there is a edge between 1 and 2, we will mark here 1. 1 2 1 2 1 1 1 1 no to 0. So 1 2 yes, 2 1 yes, 1 3 no, 1 4 yes, 4 1 yes, 2 1 2 2 0, 2 3 yes, 3 2 yes, 2 4 no, 3 1 no, 3 3 no, 3 4 yes, 4 2 no, 4 3 yes, 4 4 no. So by this we can represent the graph in our adjacency matrix. If we have this matrix, then we can redesign, or we can design this graph. And the second way is adjacency list. So if uh, like we have edge from 1 to 4. So with node 1, we will store what is the neighbor of 1. So we will store 2 and 4 here. In 2 we will store 3 and 1 here. And with 3 we will store 2 and 4 here. With 4 we will store 1 and 3 here. So by this way, we can recreate this graph if we have this information. So this is two representation of graph, and I think it's easy to code. So here, creating adjacency matrix. This is for directed graph. So pretty easy thing. Connected component logic. So we are seeing the different type of graphs can be connected or can be binary tree, graph traversal. So basically the connected graph is connected graph like this and this. This is one connected graph, and this is another connected graph. So we can't go from this to this. So this is not connected, but these are interconnected. So this is very simple thing. So next is the BFS representation and DFS representation. Mm-hmm. We will solve this question. Representation of graph. Mm-hmm. BFS of a graph. So, so to traverse a graph, we have a two method, and the first one is BFS, and the other one is DFS. Like one, two, three, four, 5 and 6. So with BFS, if we start from 1, then we will move in the every width first, breadth first, this way and this way. And if we move with respect to DFS, then we will move from 1, then 2, then 3. Then we will come back to 2, then we will move to 4. Then we will come back to 2, then we will come back to 1, then we will go to 5, then we will go to 6, then we will come back to 5 and come back to 1. So this is the DFS way to traverse, and this is the BFS way to traverse. So in question, which traversal we need to use depends on the requirement. And here we will code the BFS way also and the DFS way also. So how we should traverse in BFS? So BFS traversal 1, 2, 3, 4, 5, 6, 7. So while solving BFS, the most obvious way is to have a queue. Queue is the first in, first out. क्यों इज लास्ट इन फर्स्ट आउट क्यू में क्यू में ऐसा होता है इन क्यू द एलिमेंट्स विच कम फर्स्ट विल गो फर्स्ट फीफो फर्स्ट इन फर्स्ट आउट so here we will get 1 and then we will see what is the neighbor of 1, then it is 2, and then it is 3. So we will store 1 and then erase 1 and store 2 and 3. कॉल आ रहा है मेरे फादर का. जी पापा. हाँ. हाँ ठीक है. हम्म. हाँ ठीक है. हम्म. ठीक है. ओके. So 2 and 3, and then we will get 2, and with 2 we have connected 4 and 5. So we will also enter 4 and 5, and 2 will go out, and then we will get 3. So with 3 there's 6, so we will write 6 and 3 will go out. Then with 4, then with 5, then at 6. So 1 2 3 4 5 6. So this way we can traverse BFS by having Q. And we can also use priority queue, which is type of queue. So and for DFS, we can use recursive method. For DFS, we can use recursive method. 1 2 3 4 5 6. Recursive method, we will go 1 to 2, then 3, then come back. So it's like a backtracking thing, pretty easy. So let's implement both. BFS representation of graph. Q int vector of an adjacency list. Mm, mm, Size Q int Q dot push 0. Q dot push. For auto ID adjacent of node. Uh, Q dot push ID. Answer not push back node. Ego teacher and 1 2 3 4 5 and 0. Where's 0 equal 1. If with of ID. Continue. With of ID equal to 1. Hmm. Traversial Q dot portion is on same calculation can be done. Uh, with of IT equal to 1. If it's already visited, then it's continue. Mm, Control C, Control V. 0 to 1 into not answer not Q not front Q not pop. Mm, Ways of fighting equal to 1. Ways of fighting equal to 1. Ways of if not visited of fighting Q dot push fighting 3 1. And if not visited Q dot push fighting then of fighting equal to 1. Ignoring not front Q and Q dot turn the not push. Mm, mm, Error in my code. Mm, mm, okay, so I made this mistake here. Ways of 0 equal to 1. Mm, so this is the standard way to write BFS. First we will declare Q and mark with 0 equal to 1 here, like the root node. Here we assume that the root node is 0. Mm, uh, and here we have pushed the node. Q dot push answer dot push back. Answer dot push back 0. Okay. Uh, let's write DFS way to traverse in a graph. Vector int answer. Values in node in parent. In parent. father's node is visited. Mm-hmm. Parent, parent and visited. Mm, crazy. Mm-hmm. And pushback node. Difference zero parent, zero visitant, and then send return answer. Mm-hmm. 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 So we have solved the DFS way also. It's pretty easy. Mm-hmm. So now see problem on BFS. This is pretty big list. Number of provinces lead code. Mm-hmm. Mm-hmm. 547 number of provinces. So we have solved this question and it is pretty easy way. And city sum of number connected and we have to calculate the number of provinces. So it's the one of the most easiest question in this series is connected. So we have given adjacency matrix. We need to convert it into adjacency list. Ha 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 ha. Hmm. And the question is pretty easy to solve. Like we need to count the number of connected components, number of provinces. There are in cities, some of them are connected while some are not. If city A is connected directly with city B, city B is connected directly with city C, then C and then A is connected indirectly with C. A province is a group of directly or indirectly connected cities and no other cities outside the group. You are given cities, you tell the total number of provinces. So the approach is like this, this, and this, and this, this. So everyone has a name 1, 2, 3, 4, 5, 6, 7, 8, 9. So our approach will be like we will use DFS method, and DFS will traverse this and this, and will mark 1 2 3 4 will be 1 1 1 1, 5 6 7 8 9 will still be 0 0 0 0 0. So this will be this DFS will be end here because there is no connected component. So we have to iterate from for I equal to 0 to I equal to 1 to n 1 to 9, and we will start DFS with every node, but it should mark with 0. If it's 1, like if we will iterate from 1, first will be 1, so it will mark all the element till 4 because it is connected component. And then in this loop, when I will be 2, then it is already visited, so we will not visit this. So in this way, our second DFS will start from 5, and this will mark 6, 1 and 1. So we will calculate here like in which number of nodes we are going to do DFS, and it will also return this answer. So we will do DFS with node 1, then 5, then 7. And this way we will get three number of provinces. But firstly we need to prepare adjacency list, vector of int adjacency list, and vector of int n. I control. So the it is from 1 to n. If not visited of I answer plus the offense I visited adjacency list. Not and Mm-hmm. Yes, IT node. Yes, IT node is an adjacency list. Mm-hmm. 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 That I know the it's not like and then plus one. Mm, okay. Mm, 1 1 0. Okay, here we have done a mistake. 1 to n, but the is connected is only supporting with 0 to 3. Like here n equal to n will be 3, but we are mm, accessing third index, which will give incorrect answer. So we can start from 0. Mm-hmm. Mm-hmm. So it got AC. Connected components problem in matrix. Given an anagram consisting of given minus and number and an order number. Connected component is a subset of like, a connected component. Finding number of connected components in the graph. Mm, Now for the no V vertex, V vertex, and mm, the either is number AIBI. Mm, I think both the question are same. Components in matrix. Both questions are same, but I don't think so. Mm-hmm. Both problem ask you treat the graph as undirected. And if an input format in graph, you must adjacency list has a adjacency matrix. So the only difference is the input format. Rest are the same.